Okay, multiplying rational expressions. So there's a few steps that you have to follow when you are multiplying and dividing rational expressions. So the first thing you need to do when you're multiplying is to factor the numerator and denominator when possible. Okay, and then once you do that, cross out your matches. One from the top and one from the bottom. And then you write what's left. Okay, so when you're multiplying rational expressions, it's literally just a bigger simplifying problem. Okay, so it's the same exact process. Essentially, you just have more that you could cross out and more that you're going to have to factor. So in number 1, I'm going to look at all the numerators and denominators and see what I could factor out. Well, I'm looking at this numerator right here, and I see that I could factor out a GCF. And there's a GCF of 3x. So I'm going to take out the 3x, and what I have left is x plus 8 over x plus 8 times 1 over, so I'm looking at this denominator, there's a GCF. I'm going to factor out the 3, and then I have x plus 3. Okay, so I'm going to cross out something from the top that matches with something from the bottom. It doesn't have to be in the same fraction. It could be in the other fraction, just so long as one's from the top, one's from the bottom. So the x plus 8 cancels out. And remember, when you factor out a GCF, that's fair game to now cross out. It's not a part of your binomial anymore, so you could simplify that with stuff. Well, I have a 3 in the top and a 3 in the bottom, so those are going to cancel with each other. And then I don't see anything else that matches. So I'm going to write what's left in the numerator. I see an x and I see a 1, okay? And you're going to multiply those together, which is just x. And then what I see in the denominator is just x plus 3. Okay, and this is going to be my final answer because the x in the denominator is part of the binomial. It's attached by addition. So that can't get crossed out. Either the x plus 3 as a whole gets crossed out or nothing gets crossed out. Remember, that's a package deal. So you have to leave your answer as is. So in number 2, same thing. In the first fraction, I don't see anything that I could simplify. But I can factor in the numerator in the second, so that's going to be n minus 5, n minus 4, right? Those multiply to be positive 20, but add to be negative 9. And then in the denominator, I'm looking for numbers that multiply to be negative 28, but add to be positive 3. That's n plus 7, n minus 4. Okay, so now I'm looking for things that match. Well, I could cross out the entire n minus 4. And then I see an n plus 7 here and an n plus 7 here, and I'm going to cross those out. So all I have left in the numerator is n minus 5. What I have left in the denominator, 6. And then this is your final answer. Okay, number 3. In the numerator, we can factor. You guys always forget about this. When you have two terms, you could still factor if you look for a GCF. So they both have 5 in common, so I'm going to pull out the 5, and that gives me x plus 5 left in the parentheses. And then in the denominator, there's a GCF of 10x, and I have x minus 1 left in the parentheses. Okay, and then over here, I have 16 as the GCF, and then I have x minus 1 left over 5. Okay, so now I'm looking for things that match. The x minus 1, I could cross that out as a whole. These 5s, now that they're just monomials, they're not a part of a binomial, I could cross those out. And 10 and 16 actually have something in common. I could divide both of those by 2. So that's going to become 5, and that's going to become 8. And then I don't see anything else that I could cross out. So in the numerator, I have 8 and x plus 5 left. So I'm going to write 8 and then leave in the parentheses the x plus 5. over. In the denominator, I have 5x left. You do not have to multiply the 8 back in. You can leave your answer like this and save yourself some time. Again, you can't cross out the 5's and you can't cross out the x's because this x and this 5 are in a binomial and you can't break up a binomial. Okay, number 4. Before I even factor, I see right away I have something in the numerator that matches exactly with something in the denominator. Notice that this and this are exactly the same. So don't even factor it, you're just wasting your time. Since they are exactly the same, I could cross the whole thing out. Okay, again, the only way you could cross it out is if the whole thing matches exactly. If there was not a 56 and one of them was a 49, well then you can't cross it out. Okay, they have to be exactly the same. So I'm going to cross those out. And I'm going to factor the denominator over here, and I'm going to rewrite this as one fraction. So I see I only have x plus 5 left in the numerator, so I'm going to write x plus 5 over, and I'm going to factor that x squared plus 9x plus 20. So that's x plus 5, x plus 4. Now these x plus 5's match, so I'm going to cross those out, and when you have nothing left in your numerator, we put a 1 over, and then what I have left in the denominator is x plus 4. You could leave it in the parentheses or you could take it out of the parentheses. It doesn't matter. Okay, and then that's our final answer. Okay, dividing rational expressions. So dividing rational expressions is literally the same exact process as multiplying. You just have to do one step before you do that. Okay, and we have to keep, change, flip. Something I want you to be aware of, though, is you can't not simplify when it's a division problem. What I mean by that is you can't cross cancel. So see how there's an x plus 7 here and an x plus 7 here? You can't cross those out because right now this is a division problem, so it doesn't work like that. You could simplify it within the same fraction if you were able to. In this case, we aren't, but you can't cross cancel while it's division. So what you're going to do is change this to multiplication first. So remember, we keep the first fraction the same. We change to multiplication, and then you flip the second fraction. So the second fraction becomes x squared minus x minus 56 over x plus 7. See, now that it's a multiplication problem, those x plus 7's aren't going to cancel out. Those are on the same level. You can't cross out things that match if they're on the same level. So if they're both in the denominator, they're not going to cancel out. You always need something from the numerator and something from the denominator in order to cross out. So now that I changed it into a multiplication problem, I'm going to do the same steps as before. So it's the same exact thing. Look for things to factor. So I could factor that numerator. That's x minus 8, x plus 7 over x plus 7. Now I see an x plus 7 in the numerator and I see two x plus 7's in the denominator. Well, you can only cross out a pair. So if I cross out the x plus 7 in the numerator, I can only cross it out with one of the x plus 7's in the denominator, but it doesn't matter which one it is. Okay, I could cross out the one right underneath, or I could cross out this one over here. Just as long as it's one, you're fine. Okay, those 7's are not going to cross out because the 7 in the denominator is part of a binomial. It's attached by addition. I can't touch it. Okay, so what I have left is 7 and x minus 8 in the numerator. I need the parentheses. And then I have x plus 7 left in the denominator. And we are done. Okay, same thing with number 6. So I'm going to keep this first fraction, change multiplication, flip the second fraction. So I'm noticing that this denominator is the same as this numerator, so I'm not even going to factor that. I'm going to go ahead and cross those out right away. Okay, they're exactly the same. I could cross them out as a whole. I just can't cross out pieces of them. Okay, so what I have left is 6x plus 15 over 14x plus 35, but I'm not done simplifying. I see that there's a GCF in the numerator, which is 3. So I get 2x plus 5 in my parentheses. And then there's a GCF of 7, which gets me 2x plus 5. I see parentheses that match, so I'm going to cross those out as a whole. So all I have left is 3 over 7. Okay, go ahead and do the U-tries and pause the video and then come back and see if you get the same things as I do. Okay, number 7, I don't see anything that I could cross out right away, so I'm going to go ahead and factor everything that I can. So in the numerator, I get x plus 8 and x plus 5, right? Those multiply to be 40 and add to be 13. And now this is a multiplication problem, so I don't have to flip anything. So I'm just going to factor and keep everything else as is. So x plus 4, x minus 1, and x plus 5, x minus 1. So I'm going to go ahead and start crossing things out. So I see these x plus 4s match, the x minus 1 match, x plus 5, and all I have left is x plus 8. You don't have to put it over 1. Since there's nothing left in the denominator, you could put a 1, but that's not necessary. That's like having your answers 2 and then writing it as 2 over 1. Okay, so we're just going to leave our answer as x plus 8. You don't need the parentheses because nothing's multiplying by it. Okay, and this last one, if you want to factor right away, you can as you're flipping it. So I see that I could factor out a GCF of 3 in the numerator and a GCF of 3 in the denominator. Change the multiplication. I know this p squared plus 10p plus 21 is going to be in the numerator, so I'm just going to factor that right away. That's going to become p plus 3, p plus 7 over 4 minus p. Okay, you don't have to factor right away if you don't want to, and I'm just trying to save you a little bit of work. So I see that these 3's that are the GCFs are not a part of the binomial anymore, so you're allowed to cross those out. So these match. These p plus 3's match. And notice that these have the same two numbers but opposite signs. Hopefully you recall what we did when you see the same two numbers but they have the opposite sign is you could factor out a -1 and that'll change the sign. So if I take out a -1 in the denominator, that p is going to become positive and that 4 is going to become negative. Okay, so if you take out the -1, it's going to change both of these signs. Okay, and then I'm just writing it in a different order so it matches the one in the numerator. So now that these are exactly the same, I'm going to cross out the p minus 4's. And you can leave it as p plus 7 over -1, but it's more proper to write it outside of the parentheses. And if you really wanted to, you could distribute the -1 and make that -p minus 7. But I would accept both of these answers. Even if you left it over -1, I would also accept that as an answer as well. Okay, last part is complex fractions. Some of you may have seen these, some of you may have not. And if you have seen them, you probably didn't know what they were called. So these are called complex fractions. What complex fractions are fractions within fractions. Okay, so this right here, this is called our main fraction bar. And hopefully you guys remember that if you have a fraction, you actually have a division problem. So our main fraction bar is acting as a division symbol. So what this problem is actually saying is whatever in the numerator divided by whatever in the denominator. So what I'm going to do is rewrite this as a division problem. So the numerator is being separated from the denominator by that main fraction bar. And that's how you're going to figure out your two fractions. So it's going to be 16 over x squared. So you read it from top to bottom. And then since I hit the main fraction bar instead of the main fraction bar, I'm going to write a division sign. And then I'm going to write the denominator, 4 over x. Well, you just saw this. You just learned how to do this. All I have to do to divide this is keep, change, flip. Okay, and these are monomial, so there's nothing I need to factor. I'm literally just going to start simplifying things in the numerator with things in the denominator that match. So I could simplify 16 and 4, right? 4 goes into 16 4 times. This x will cancel out one of these x's, so what I have left in the numerator is 4. What I have left in the denominator is x, and then we are done. So these problems actually look a lot scarier than they are, but you already know how to do these. Okay, you just didn't know that yet. So in number 10, here's one fraction, here's another fraction. Okay, here's my main fraction bar, so that's going to count as my division symbol. So I'm going to rewrite this as a division problem. So it's m minus 4 over m plus 3 divided by m minus 4, 3m plus 1. Okay, and then we keep change flip. So keep this first fraction, change the multiplication, flip the second fraction. Okay, I don't see anything that I could factor, but I do see binomials that match. So these match each other. I don't see anything else that I could cross out. So what I have left in the numerator is 3m plus 1. And in the denominator, I have m plus 3. And that is your final answer. Okay, last two, I believe. Yes. Okay, I want you to look at this right now and think to yourself, how would you separate these into two fractions before I actually write it out? Okay, so take a second, look at it. How would you rewrite this problem? Okay, luckily you identified your main fraction bars right here, and that's kind of creating our division problem. So I have x plus 3 over x squared plus 6x minus 7 divided by, write it from top to bottom, over x plus 7. Okay, now I'm going to keep change flip. I'm going to factor as I go, so I have less steps to do when I'm simplifying. So I'm going to keep this one the same, but I'm going to factor the denominator right here, so that's x plus 7, x minus 1, times, well, this x plus 7 over here is going to be in the numerator now, and I got to factor that denominator. So 2x and x go in the front. And I'm going to guess 3 here, 1 here. So that's 6 plus 1, that gets me 7. So I factored that right. And now let's see, can I cross anything out? So I could cross out this x plus 3. I could cross out this x plus 7. So I see that I have nothing left in the numerator, which means there's just a 1 left. Okay, and then in the denominator, I have an x minus 1 and a 2x plus 1, and we are done. Okay, lastly, number 12. Again, start thinking to yourself, where would I separate this? And that would be right here, right down the middle. That's where our division sign is. If you want to start factoring right away, you can. I'm not going to, just so people could see what I'm doing. So x squared minus 49, and then x squared plus 10x plus 24 divided by, you could also flip it right away if you want to too. I'm okay with you skipping a few steps for the sake of time. But I'm going to go ahead and start factoring right now. So in the first numerator, that's a difference of 2 squares. Lots of us I saw on our simplifying homework forgot how to factor a difference of 2 squares. Okay, remember it's 2 perfect squares being subtracted. So x squared is a perfect square, 49 is a perfect square, and I have that minus sign. So what you do is you take the square root of x squared, which is x, so that's the front of my parentheses. Then you take the square root of 49, that's 7 and 7, 1's plus, 1's minus, and then you're done. Okay, in this denominator, that's going to become x plus 6, x plus 10. Then I'm going to change this to multiplication, and I know this is going to go into the numerator, another difference of 2 squares. Okay, so the square root of x squared is x, the square root of 16 is 4, 1's plus, 1's minus, all over. Now I'm going to factor what was the numerator, now it's becoming the denominator. So x plus 7, x minus 4. So now let's start looking for things that match. I have an x minus 4 that matches with the numerator. I have x plus 7, and then I don't see anything else. Oh, I wrote this wrong, that's why. This should be x plus 4. So now the x plus 4s are going to cancel, and then I have x minus 7 over x plus 6, and we are done.